Hello, my name is Priyam Poddar, and this is my project for the Congressional App Challenge. Millions of people rely on sign language to communicate, and Sign AI uses artificial intelligence to bridge the gap between deaf and hearing communities. Over 34 million Americans have significant hearing loss, and more than 90% of deaf children are born to hearing parents, making everyday communication difficult. And even later in life, only about 55% of deaf adults are employed, compared to 70% of hearing adults, showing how important communication is for inclusion and opportunity. So we need accessible ASL translation that works anywhere and anytime. There are 500,000 ASL users, but only about 10,000 interpreters, leaving huge gaps, especially in rural and low-income areas. ASL learning demand is rising, with classes in about 4% of US schools, so students need an easier way to learn ASL. So my goal is to create an AI system that anyone can use with just a camera. Sign AI translates ASL gestures from video into clear English sentences in real time. It's fast, accurate, and works like a digital interpreter. It also helps ASL learners by giving instant AI feedback on their signs. Most existing translators use static images, recognizing one hand shape at a time, only about 0.2% of real ASL. ASL grammar and English are totally different, so simple image models can't build sentences. My system processes continuous video, tracks movement, and reconstructs coherent English, something that very few projects attempt. So this project took about 8 months. I researched current tools, designed AI architectures, and trained multiple prototypes, so some running for days due to large datasets. After 10 iterations, one model finally succeeded, which balanced speed and accuracy. So in the end, I built two systems. One translated video into coherent sentences for about a 40-word vocabulary, and the other recognized 300 ASL words with 80% accuracy. But it couldn't yet form sentences due to limited compute power and variation. However, combined and with more compute power, this could scale into a full everyday communication tool for millions. Now, let's see it in action. Presenting Sign AI, your hands, your voice, and your story. So this is the demonstration of my app. So if we come over here, we'll see that we have 3 buttons. We have a how to use button, a start button, and a stop button. So if I press start, it should start a 3-second countdown, and I'll sign a word. Okay. Press stop and infer, it should give us a result, which is bed. And that was the word I signed. So let's start again. And this time it's going to be a more advanced word. So I'll apologize because I'm not the best signer. But let's start it and see if it works. Okay, that's supposed to be computer, and that was the number one choice. So our model worked. Okay, now this is me with the model that can record and translate in real time, but only on about 40 words. At the end, I press a button that runs an LLM over the detected words and translates it to coherent English sentences. Okay, ready. Okay, perfect.
Sign AI is in the very early stages of its development, but it is already showing the potential to be a great tool to help students learn sign language and to help communication between deaf people and hearing people. Once fully developed, it will be able to translate from American Sign Language into English, and when done, that will be a very helpful tool.
Thank you for watching my demonstration, and remember, your hands, your voice, and your story. Okay, so the demonstration is over, but if you would like to learn a little bit more about how this works, then here's a quick overview. So the dataset that I used was the word level ASL dataset, which includes over 12,000 videos representing more than 2,000 ASL words. And because it has this many words, I actually didn't use all of them because that would require a lot more computational power, which I did not have at my computer at home. And for consistency, I pre-processed every video to be 64 frames long and resized them to 256 by 256 pixels. And my early prototypes used pose estimation with MediaPipe, extracting X and Y coordinates of the hand and body landmarks. And I experimented with 3 main model types. The first one was a 3D convolutional neural network to capture movement over time, a CNN combined with an LSTM to add memory for sequential gestures, and lastly, a CNN with a transformer, using attention to better understand context. And the final model was an inflated 3D convolutional neural network pre-trained on the action recognition on an action recognition dataset, then fine-tuned on WASL data for much higher accuracy. And it used raw videos instead of posed landmarks and achieved a good performance across 300 ASL words, more than any of the other models which I used, which got similar accuracies on only 40 words. So to go from words to sentences, I built two components. The first of which was a classifier, which runs on sliding 64-frame videos to detect ASL words in real time. And the second of which was a synthesizer, a lightweight LLM transformer model similar to ChatGPT but smaller, that converts recognized words into coherent English sentences using Mistral 7B Instruct. Together, these systems make SignAI capable of translating continuous ASL video into natural English, bridging the communication barrier between the hearing and the deaf. Thanks for watching, and remember, your hands, your voice, and your story.